Welcome back, folks. Today in 6.4 we're going to talk about something called enhanced for loops, also known as for each loops. Now this is a topic we're going to introduce using arrays, but it's actually something that will work for several other data structures, and we'll use it as we go through the rest of the semester. Okay, so let's get going with enhanced for loops. So what I have on this slide is our most common looping pattern for processing arrays. So we have an int array called nums filled with some int values. And then we're going to process that array with a for loop with our counter variable starting at spot 0 for the 0th element of the array, running while spot is less than nums.length and counting up by 1 each time. This basic pattern here is going to allow us to run through each value in that array and process it some way. Okay, here for this example, we're just going to print them off. So our output would just be the different values in the array. Okay, as we go through the semester, we've seen some variations on this pattern, but typically when we want to do something with an array, we want to start at spot 0, run through the length, one spot at a time, and again process that array. Now this pattern is so common that in Java we have a shortcut called the for each loop. So what I have on the slide now is the corresponding for each loop. Again, I have the same int array of nums, and what this is going to do is for each int I in the array nums, we're going to print out that I. This will give us the exact same output, and as you can see, that for each loop is going to be a little more compact, be a little kind of cleaner to read than the typical for loop. Now our general pattern for the for each loop is going to be this. We'll have some type of array, where the data type is here. Now that could be a primitive like an int or a double or any type of object. We'll give it a name and we'll say it's filled with data some way, somehow. Okay, the way we'll write the for each loop is we'll say for each, first we give it a data type. We tell that loop what type of data to expect. And then we have to identify a temp variable that's going to take on the elements of the array, followed by the array name. And the way we'd read this is for each data type temp variable in array name. Then we'll give it instructions for what to do with that temp variable. Okay, what the for each loop is going to do is it's going to iterate through each element in the array, and then for each element, temp var takes on its value. Now, for each loop is going to be a very convenient coding structure to use, but there's some limitations to it. The first is that it always starts with the beginning and ends with the last element in our array. Now usually when we're processing the arrays, we want to run through the whole thing, so this isn't a big deal. But if we did have a situation where we didn't want to use the entire array, we can't use the for each loop. Also, it only gives access to the elements in the array, not the actual indexes. So this is going to limit us on how we can actually process that data. Basically, we can't change the values in the array because, again, we don't have access to the index. We only have a temporary variable with the array values. So let's go ahead and look at some of our common algorithms we do with for loops and then the corresponding for each loop code. So a common thing we'll do with arrays is accumulating, adding up all the values in that array. So let's say I have a double array called decimals filled with some double values. And we start off with a sum equals 0. Okay, for int I equals 0, while I is less than decimals.length, I plus plus. So running through that entire array, we could say sum plus equals decimals at I. Okay, now the corresponding for each loop would look like this. We could say, or we could write that for each double dec. We can give it any name here we want. We'll just call it dec for decimals. In the decimals array, sum plus equals that dec. Okay, that temporary variable dec is going to take on the different values in our decimals array, just like we did here with our counter variable. Again, it's a little shorter, a little sweeter, a little more compact. And as we get into some more complicated code, it's going to kind of simplify the way we can read it. Now, another common thing we do with arrays is counting. Okay, counting how many times a certain event occurs. So for example, let's say we have a string array called words with some strings in it. Let's set our count to 0. Let's run through that array, int I equals 0, while I is less than words.length, I++. And then here we'll say if words at I, so if the string in the words array at index I equals CSA, we'll add to that count plus plus. Now the corresponding for each loop would look like this. For each string, we'll call the temp variable word in the array words. Okay, if word, that temp variable, dot equals CSA, we'll add to the count. Again, same thing happening here, just a little shorter, a little sweeter, a little more compact, a little easier to read, I'd say as well. Now there's going to be certain things that a for each loop can't do. For example, copying array elements. So again, this is a typical pattern we have. Let's say we have an int array called nums filled with some ints. And we want to make a copy of that array without just copying the reference, but actually copying the elements. We have two separate arrays. Well, to do that in the past, we've said int copy equals new int array with the same length as nums, so sizing it with nums.length. And then what we do is we could run through or loop through either nums or copy since they have the same length. And for each index at copy, we just set it equal to the index at nums. Okay, this would successfully fill a second array with the same value as our first array. Okay, now we can't actually copy the values with an enhanced for loop because I don't have any access to the index to tell it where to put anything at. Okay, when I say for each int I in nums, all that's giving me are the specific values. It doesn't actually access the indices of those values. It just runs through the values. Okay, could we force this to work somehow with some additional counting variables? Yep, absolutely. But by the time we do that, we might as well just use a for loop as opposed to a for each loop. Now another thing we can't do with a for each loop is make any changes to the array. Okay, and changing the array by updating its values is something we've used loops for. So again, let's say I have the int array nums with some ints in it. And let's say I want to run through it, and for each spot I want to add 1 to what's already there. So nums at I gets the value of nums at I plus 1. Okay, again, I can't change the values of the array because I have no index variable. I have no way to actually access the spot things are at. Okay, this I, this temporary kind of variable that takes on the different values in nums, doesn't come along with an index, so I'm not actually able to say where I want to make any changes. All right, so that's it for our enhanced for loops or for each loops. Now, as far as what you need to be able to do with them, multiple choice time, you do need to be able to read for each loops, write for each loops, and especially identify when they're equivalent to our normal for loops or while loops. Okay, free response time though, there's never going to be a question where they say you have to use an enhanced for loop. Okay, basically it's up to you as to whether or not you want to use a for loop or a for each loop based on the situation. Okay, hopefully as we go through class, you get comfortable with them and see the advantages of them and take advantage of the way they work. And as we go through the next few chapters, they're going to work for our different data structures. So this won't be something that just shows up for arrays. It'll be something that shows up really the rest of the semester. All right, that's all we got. Work on some programs, crank out some code, and like usual, if you need help, let us know. We'll be here to help you out.